Thank you, Jason. We are members of the iTwin platform group, and what the iTwin platform provides you is a collection of services to help you build your solution around digital twins. There are many different services that we provide as part of the iTwin platform. These services can be used to help you build your own solution for digital twins, and we'll concentrate today's talk on synchronization. We can see various services listed here, and clicking on these will go into details on that particular service. Note that all the links that we will be using today will be provided in the chat window at the end of the webinar. Let's get some definitions over with first, and then we can go into our various options on synchronization. Let's start off, what is a digital twin? Basically, it is a digital representation of a physical asset, process, or system. An iTwin is an infrastructure digital twin. Synchronization is where you use a connector to get data from your source application into the iTwin. Synchronization can be of many different files or models into a single iTwin, and these different files or models can come from a variety of software applications. Typically, synchronization will happen many times to capture all of the changes being made to the source models through the life of the asset. The connectors manage this change and only update the iTwin with the changes that have been made. What is a connector? Connector is an application that converts the data from a source application into an iTwin. Generally, a connector will be specific to an application or format. For example, there is a connector for MicroStation, there is a different connector for AutoCAD, and there's a different connector for Revit. Synchronization will bring in different models from different sources into your iTwin. What does it bring into the iTwin? It will bring in the graphics from the source models, the data associated to the objects in that model, and the relationships, so that you can use this in whatever you have planned with your iTwin. But once you import it into an iTwin, synchronization does not stop there, because your source models will change over time. When we run synchronization again, we will only update the iTwin with the changes made to the source data. These changes are tracked within the iTwin, and this information can be used for things like version comparison during visualization. To keep track of all your models synchronizing into the iTwin, you can also automate the updates. Basically, synchronization is often the main source of data in the iTwin, and once you have that data, then you can perform other functions with that data. The iTwin platform gives you various options in how you can synchronize into an iTwin. You can use our demonstration portal if you like. That allows you to synchronize easily for some of the most common formats, and you don't even need to code anything in order to use this. If you want to run cloud synchronization, but you don't want to use the demo portal, that's fine. The APIs allow you to develop a solution yourself for cloud-based synchronization. You can also use the iTwin Synchronizer to run synchronizations from the desktop. Let's do a very simple example where I want to create an iTwin and visualize the model in a web browser. We'll do that by using our demonstration portal, and we'll be using the synchronization service followed by the visualization service from the iTwin platform. Ahead of time, I've already created a project and I've created an empty model. A little side note here, the source for this demonstration portal that I'm using is available on GitHub, which you can use as an example or starting point, and it's going to show you uses of some of our iTwin services. We have this Revit model, and we're going to create an iTwin by taking the file and synchronizing it. In this portal, all we have to do is drag it onto the tile. Dragging the file onto this tile will upload the model to the cloud and run the correct connector to convert the Revit model to the iTwin. Peter's demonstration coming up will show how you can use these APIs to create equivalent functionality that is being used in this demonstration portal. What kinds of applications and file formats are supported by synchronization? On our community site, we list the various Bentley applications and what connectors are used to import the data, as well as third-party applications that we have developed specific connectors for that will import the models into an iTwin. Finally, we have a listing of different file formats that are supported by various connectors. Now that the model has been synchronized, we can visualize the model. The outcome of the synchronization is that we have imported the graphics, data, and relationships provided by the source model. We could have imported multiple Revit models, as well as models from different applications, all into the same iTwin. In this case, we created the iTwin so that we could visualize it. But by having all of our data in the iTwin, we can do many other things, including your own functionality that you may have or may plan on developing. Perhaps you would leverage the other services provided by the iTwin platform, such as reporting or validation, to provide some additional functionality for your users. So that is a quick overview of synchronization. I've given one option of how you can synchronize data into an iTwin using an existing portal, and now Peter will show us another one of our options where we can use synchronization APIs. Over to you, Peter.
Thank you, Tim. Hi, everyone. My name is Peter Senft, and I'm a software engineer in the iTwin platform group. Today, I will introduce you to the iTwin Synchronization API and show you how to use it to synchronize the data in your design files to an iModel. The Synchronization API is one of many in Bentley's portfolio of APIs to build applications around a digital twin. It gives you access to our cloud synchronization service, which is designed to synchronize source data that resides in our cloud storage service into an iModel. The connectors are running on machines in the cloud, and we are currently supporting many different types of source files, like MicroStation, Revit, IFC, DWG, and so on. The full list can be found in the API documentation and is updated when new connectors are added. So let's have a look at how we can use the API to create, run, and maintain synchronizations. I already navigated to developer.bentley.com. This is where all our API documentation lies, and at the top menu we have the documentation point. And in here we find synchronization exports and the synchronization API itself. The synchronization API is divided in 4 different categories. We have first the authorization, then a general connections endpoint for how we can get connections for an iModel, then the endpoints where we can maintain the connections themselves, and then the endpoints where we can maintain the files that are associated with a connection. Also, I mentioned that the list of supported formats can be found in the documentation. You can find it with this link. As you can see, there's a variety of Bentley applications, third-party applications, and interchange formats that are all supported by the synchronization service. But now let's take a look at the authorization endpoints. Here we have get authorization information. The cloud synchronization service is a backend service, and it needs to be authorized by the user to perform its tasks. The authorization information endpoint is used to check whether that authorization was given, and if not, provide a URL that the user can be authorized. So let's check if my current user is authorized to use the service or not. We can try the endpoints right from here from the documentation using the Try It Now or Try It Out button. Because the authorization information endpoint also provides a URL to perform the authorization, it needs to have a redirect URL as an input parameter. This URL points to an endpoint in your own application that is checking whether the authorization was successfully given or not. For demo purposes, I just put a dummy localhost URL in here, so let's do that. And we're using my current user to authorize. I'm already logged in, otherwise you would have seen a login screen here. And now we can execute this query. As a result, we see that my current user is not authorized, and to authorize, we were given this URL. So let's use this URL to authenticate or authorize. I copied it already, so let's paste it here. We will be now redirected to Bentley's IMS service, and the service is requesting approval for a variety of scopes that are all necessary to run the synchronization service. So in order to do that, we have to now allow all these scopes to be used. Click Allow, and the system will now redirect us back to the URL that I gave in the initial request, which of course in this case fail. But we see in the URL that we are now authenticated supposedly, so let's see if that is really true. Let's execute this query again, and it should give us now that my user is authorized. Now that we are authorized, we can start creating connections. Therefore, we go to the post call to create a storage connection. Before we can do that, we have to create an iModel and also upload whatever source files we have into the storage service. We can use the APIs that are described in the documentation for that. I did this already up front, and let's try to create a new connection. In this case, we have a new connection. I will call it webinar test 1 test. We have our iModel ID of the iModel that I created and 3 source files that are in file storage. One I want to synchronize using MicroStation, the other IFC, and the last one is a Rapid file. Let's get authorized and execute. As a result, we get a new connection. We have an ID. Let's capture this ID here so that we can use it for our future queries. We see it's connected to an iModel, to a project, here direct links via the API, and we also see this connection is brand new, it never ran. We have now a connection, so let's see if it also shows up on the iModel. Let's copy the iModel ID and go to the Get Connections endpoint. Try it out. And here we have our iModel ID. We can also give parameters top and skip to define paging if we have a lot of connections on an iModel, but in this case I don't expect to see much, so let's authorize and execute. As you can see, we have actually 2 connections defined here, one that I just created, our webinar test 1 test, and a webinar test 2. And down here you see 3 links for navigation through the list of connections. In this case, it's kind of all the same because we have only 2 connections. And let's take a look at if we can get a little bit more detail about this connection. Let's take our test 2 in this case. So maybe there's a little bit more detail about this one because we have not looked at this one. Therefore, we go to the Get Storage Connection endpoint, try it out, take a look at this connection, and execute. We see a little bit more information here. We see the iModel ID, the project ID, corresponding links to the API calls, and actually this connection ran one time and we have a link to the specific synchronization run. So it's cool, we have another connection and it ran already, and we have a brand new connection. So we know now our connection is available, everything seems to be fine. So let's run the connection. We can do this with the Run Storage Connection endpoint. Let's go to try it out. We need to have the connection ID, which I need to copy again. Authorize and execute. As a result, it's accepted. We should have a run. Connection is started. Let's see what the status is. Therefore, we can query the storage connection runs endpoint and see what we have on our connection ID in terms of runs. We can see there's currently 1 run that is waiting to execute, and the result is currently undetermined. So let's take a look while we capture this run ID. There's also, if there are more than 1 run, you have pagination links again, but in this case we have just 1 run. So let's close this and get a little bit more detail about the run itself. Go to the Get Storage Connection Run endpoint. This one now requires a connection ID and a run ID. Just copy the run ID. Let's copy the connection ID from here. Authorize and execute. Now we get a little bit more detail. So we see that we started our connection. The end time is not set yet. We are in a so-called master file phase. Means all our files are currently master files. The state is it's waiting to execute, so currently there's no node available, or the node is currently firing up for it to run. Because it's not done yet, the result is undetermined, and now we have multiple jobs. For each file, in this case we have 3 files, we have 3 jobs. The MicroStation job, the IFC job, and the Rabbit job. All 3 are currently not started, or one is waiting to execute, and the other ones are not started yet. To see what information we have if a job is actually completed, let's take a look at the job on the other connection. Let's copy the connection ID. And the run ID. Get authorized and execute. Similar to beforehand, we have a start time, but this time we have the end time set. This job ran for approximately 11 minutes. It was also just master files. It completed successfully, and here's more information about the single job itself. It completed successfully, ran DWG, and used this storage file. Next, let's take a look at the endpoints to maintain a connection after it's created. First, update storage connection. It's an endpoint to rename the connection, and we have currently a not very nice name with webinar test1 test for our newly created connection, so let's fix this. I copied already the connection ID, and the payload is more or less the same as if you were to create a connection. Let's just change the name. Everything else is the same. Authorize and execute. Now our connection is more in line with the other name, webinar test1. Now let's look at the update storage connection source file endpoint. This is an endpoint that serves 2 purposes. First, you can reassign or change the assignment of a connector, like you accidentally assigned a DWG connector to a Zipper3D file, so you can fix this here. Or if you initially selected the wrong file in storage, then you can correct the assignment and update the storage file ID in the connection source file. But in order to use this, we need to have first a source file ID, which we can get with the get storage connection source file endpoint. Let's try this, and we need to get our connection ID first. This gives you now all the source files that are currently assigned to it, and I know already it's this file here that I'm looking at, but I don't see at the moment if this is really a Revit file, so let's double check this, copy our source file ID, and get more detail with the get storage connection source file endpoint. Again, copying the connection ID. And here we see, with that ID, we assign currently this storage file to it, and we assign it to the Revit connector. So let's use and update this storage file assignment. Try it out. We have our connection ID. We have our source file ID. Let's authorize so we don't forget it. And I want to change the assignment to this here, but it should stay Revit. Let's execute this. This was the new assignment, and as a result, it's now assigned to this file. If I want to assign it back, Now we have an EO. This was XE, execute, and now it's assigned to the original file. So let's take a look at the last two endpoints that we have at our disposal. There's the add storage connection source file and remove storage connection source file. They're very straightforward, so let's, instead of changing the assignment, use this new source file, new Revit file, and add it to our connection. Let's try it out. What we need is our connection ID again. Authorize. We know it's a Revit file, and we need to have the ID of the new file. That didn't copy for some reason. Let's copy it again. And execute. And we have an additional source file now added to our connection. Just for completeness, let's remove the old one from it. We know already our source file ID from our prior queries, because that's what we need in order to remove a source file from a connection. So here's our source file ID from the old Revit file. And we need again our connection ID, authorize. And this removed the old Revit file from our connection. This concludes my demo, and now I will hand it over to Sneha, who will introduce us to running the iTwin synchronization from the desktop. Sneha, to you.
Thanks, Peter. Hello, everyone. I am Sneha Inamdar, and I'm a software engineer in the iTwin platform group. Today, I'll share with you a demo on how to use the iTwin Synchronizer for desktop to synchronize engineering data to the iModel hub and enabling the user to visualize their data. Let's begin by looking at the website where we can download the iTwin Synchronizer. The iTwin Synchronizer helps with synchronizing design changes from a desktop design tool with an iTwin in the cloud. Before one can start using the iTwin Synchronizer for desktop, a team coordinator would have to create a project and provision iModel to be used. I've downloaded and installed the iTwin Synchronizer. Here I have provided my credentials, and it has redirected me to the Allow Permissions page. And I'm logged in. At the top here, it displays the list of projects that I have access to, and I choose the project that I want to work on. I pick a test project and I click Create Connection. Here, I will start providing connection details or a connection definition where I give the connection a name, pick the iModel that I want to synchronize data to, and select a design file that I want to synchronize. Click Next. Here the synchronizer starts checking to see if the connector this file requires is enabled. If not, it asks that you enable it, so we enable it and then it allows us to save the connection. On enabling the connector, it downloads and installs it, making it available locally. Connector is now enabled and we click on Save to save the connection. Once connection is saved, it starts appearing in your list of connections for the selected project. Here, next to the connection, you have the option to edit or delete or synchronize. On click of synchronize, you get the option to add a named version. We recommend that a named version be added as it enables the visualization workflow. and we click Synchronize. As you can see, it's reporting a status of synchronization while it performs the synchronization to the iModel. If there were any issues found during synchronization, they are reported here and can be viewed in this UI that appears on click of See Issues. They can be filtered based on categories and has descriptions and details of missing file that the Revit file reference but were not available. Post synchronization, you will also find a button that takes you to the synchronized model. So click on Go to iModel, and this renders the details of the synchronization that happened on the iModel. Click on View. It's loading the iModel. Open iModel. And the viewer shows the iModel that was synchronized. In addition, the URL up here can be shared with the project stakeholders. The iTwin Synchronizer also has a UI that shows details about the connectors that it supports. The iModel connectors dialog shows the list of connectors that can be downloaded, those that are available but need to be updated, and those that can be deleted. The details of how any connector synchronizes data can be found within the logs in the staging directory. For any connection, the staging directory resides in the local app data under the iTwin Synchronizer folder, under the connection name. Here you will find the BIM file along with assignment logs, framework logs, all of which are generated during the synchronization process and contain details of how data was synchronized. The Save Log option allows us to save this data in a zip file that's easy to share. While synchronization details are maintained in the logs, the iModel Hub captures changes and maintains a change history, as I'll show on the screen. As successive synchronizations are performed, this change history will grow. The iTwin Synchronizer for Desktop Wiki can be found here, and it contains an FAQ page to help answer commonly asked questions. I hope today's demo is helpful to all who want to use the iTwin Synchronizer for Desktop. Thank you.
Thanks, Neha. The main focus of today's webinar was to talk about different options that the iTwin platform provides you to synchronize your data into an iTwin. Peter showed how you can use our synchronization APIs so that you can build your own portal and synchronize data into an iTwin by running the connectors in the cloud. And Sneha showed how you can use the iTwin Synchronizer to run the connectors directly on a user's desktop. All of this was focused on using the existing connectors developed by Bentley. We have a broad selection of connectors that we have written to support many different applications and file formats. We also continue to develop additional connectors to support our users. But there will be times when Bentley won't be developing a connector to something like one of your own internal applications. What happens then when you want to synchronize data from that application into an iTwin? To solve this problem, we have the ability for users to write their own connector. We feel this is worthy of its own webinar, and we intend to have one on this topic in the future. For now, you can whet your appetite by going to the Write a Connector page on GitHub, and you can get an overview of writing a connector, and in the future we'll have this additional webinar on this topic. We're doing a lot of work right now on the connector examples and documentation on GitHub, so there'll be a lot of additions coming up. We're planning on having a couple of examples, something that is quite simple, which is not only useful to start learning, but will also be practical for many users who may just have some data that can be manipulated to use in that simple connector. But we also want to go far beyond just a simple example, and we've committed in the future to having an open source IFC connector. We look forward to having this webinar in the future. Thank you for watching today's webinar. Now I'll pass it back to Jason.